Number 7. For a poetry contest, the minimum length of a poem is 16 lines. The maximum length is 32 lines. Write an absolute value equation that represents the minimum and maximum lengths. So with these absolute value word problems, I'm going to draw a number line to illustrate the way that you want to go about this. So this is your minimum length. This is your maximum length. When you're given a situation like this, you want to find the middle ground. What is the middle acceptable length? Okay, so halfway between 16 and 32, so you're finding the average between those, is 24. Okay, so that means that you can either be 8, in this case, lines of poetry, 8 lines less than 24, or 8 lines more than 24. So the difference between the number of lines of poetry and 24, the absolute value of that has to be equal to 8 if you're talking about the minimum and maximum lengths. And so that is the basic way that you'll solve any problem like that. Find that middle value, find the distance to each of the extremes, and then write an absolute value equation saying that the distance from that middle value is 8, whatever that distance is to each extreme. So looking at the next examples, if we have absolute value bars on both sides, it really doesn't change anything. You're still going to take the bars off and write the equation as it is. And then your second equation, you're going to take the bars off and make one side of the equation negative. And it doesn't matter which side, but I always do the right side. So see how they've put negative in front of this whole cx plus d? And so that's what you want to do there. So on number 8, for our first equation, we just take the bars off and solve that. So I'm going to subtract x and subtract 1, so I get this. And for the second equation, I put a negative out front, distribute that negative, and then solve from there. Minus 8. And here you want to really start checking. It's really important anytime you have variables on both sides. So if you plug in 7, then you get absolute value of 15 equals absolute value of 15, so that's good. If you plug in negative 3, you get absolute value of 5 equals absolute value of negative 5, which is also true. On number 9, you might be thinking that you want to do something with that 3, but you can't. You know, there's nowhere really for it to go. Like if you try to get rid of it on this side, well then it's over here being divided by this absolute value. So there's no way to get both the absolute values by themselves. So you just have to change the whole thing to parentheses. Parentheses aren't necessary there. So that's our first equation. We just take the bars off and rewrite it. And on the second equation, again, you take the bars off, but you make one side of it negative. And then these are your two equations that you're going to solve. So we've got 3x minus 12 equals 2x plus 5. So x equals 17. And 3x minus 12 equals negative 2x minus 5. We solve that. So x equals 7/5. And if you plug those in, they work. Makes the equation true both times, so they are both answers. Looking at number 10, we have variables on both sides, but we only have bars on one side. This doesn't change the process. It just means it's even more important that we check our answer for extraneous solutions. So our first equation, we just take the bars off, keep everything else the same. Second equation, take the bars off, make the right side negative, and then solve each equation. So here we're going to get 6 equals x, and here I'm going to add the 2x over, subtract 6, so I get this, and then I check. So if I plug in 6, then I would have absolute value of 6 plus 6 equals 2 times 6, which that's absolute value of 12 equals 12. That's true. So we keep that one for sure. If I plug in negative 2, I get absolute value of negative 2 plus 6 equals negative 4, because it'd be 2 times negative 2. Well, that is not true. Absolute value of 4 is what that would be equal to positive 4. So that's a goner. Number 11, take the bars off, keep that first equation the same otherwise, and second equation, make the x negative, and solve each one. So I'm going to subtract x and add 2. So I get x equals 1, add x, add 2. So then I'd have 4x equals 2, so x equals 1/2. And then we check both of these. So if I plug in 1, I'd have absolute value of 3 times 1 minus 2 equals 1, which is true. And if I plug in 1/2, I get absolute value of 3 times 1/2 minus 2 equals 1/2, which this 3 times 1/2 minus 2, that equals negative 1/2. Absolute value of negative 1/2 is 1/2, so that's true. So they both work. Number 12, we're back to having bars on both sides. So we take them off for the first equation, and on the second equation, take them off but make the right side negative and solve both. So you notice on this first equation, your x's cancel, and you get 2 equals negative 8. So this is just kind of the purpose of these last two examples, is to show you that that can happen. That just means that you don't get a solution from that equation. It doesn't mean that there's no solution overall. You still need to solve the other one. But we kind of hit a dead end with that equation. Over here, let's see what happens. So then I would have this. And if you plug that in and check, you would have absolute value of 2 plus 3 equals absolute value of 3 minus 8. So that's a true statement. Number 13, same process. Take the bars off, leave everything else the same. Take the bars off, make the right side negative. And you'll notice that the same thing is happening that happened on number 12, where we're getting a statement that's not true. Doesn't mean no solution overall, just means we don't get a solution from that equation. We need to check this one. So we distribute that negative and solve. And then check that. If you plug in negative 1/5 to both sides, it's a true statement, so that one works. You do not have to do the exit ticket for this lesson. Just make sure that you filled out the notes, and then I didn't print the homework page, but your homework page is on the next page in your packet, or the homework assignment.